All right, we're moving along now in Geometry B, Credit 2. This is lesson 12.1. So you did that without looking, which is the triangle proportionality. Well, I was looking. I'm looking at the screen. Triangle proportionality theorem. It starts on page 32. And what we're actually going to learn here really is a quicker way to do something we've already done. So if we're trying to find here in this first, we want to find the length of DG here. And we can call that X. And remember, we learned, we know that the little triangle ECD and the big triangle EFG are similar because angle E is congruent to itself. It's part of both triangles. And because these are parallel lines, these corresponding angles are congruent, so they're similar by angle. So we can say 32 is to the length of this whole side EF. 32 plus 24 is 56. And then we did 40, and then 40 plus X, and then we cross multiplied. We're not going to go through all that to solve it, but we're going to show you an easier way. So here's what it is. It turns out that when you have a triangle like this, let's look at the big triangle, and let's get rid of all this, and it's cut through by a parallel line that's parallel, or excuse me, by a line that's parallel to the third side down here, that these lengths here are proportional. So in other words, we can just say 32 is to 24 as 40 is to X. And it's that simple. That's it. So let's go ahead and solve for X, and we'll have our answer. So we cross multiply. We have 32 times X is 32X. And then going the other way, we have 40 times 24. We bring out the handy dandy calculator. We figure out that's 960. X is being multiplied by 32, so we divide by 32, and 960 divided by 32, it turns out is 30. So X is 30, which means, of course, DG is 30. And so that's a little bit less work because the original setup where we had 32 over 56 and 40 plus X, you had to, the way we learned it before, you had to distribute and all that. And so this is just a quicker and easier way of doing something that we kind of learned before. All right, so over here on number 2, on same page, bottom of page 32 there, where 12.1 is starting, they want us to find the length of Rn. All right, well, it's the same idea. The fact that the triangle's turned on its side doesn't change anything, because if you wanted to, now I can't do this big board, but you could turn your computer screen and turn it on its side, and you could set it up in a similar way, or see it in a similar way as the first one. So we would have 10 over X equals 8 over 5. And then that's it. That's it for the setup. Then we just cross multiply. 8 times X is 8X. 10 times 5 is 50. X is being multiplied by 8, so we divide by 8 to both sides. And 8 does not go into 50, so let's go divide that out. That should be some sort of a decimal, which is, yep, 6.25. So X is 6.25. And that's it. That's all you have to do with that. Just that easy, right? Easy stuff. All right, we actually only have, this is going to be a quicker video. We just have one more problem to do. And now what we're going to do is we're not going to solve for a missing side, but we're going to use the triangle proportionality theorem, in other words, what we just did, to prove two lines are parallel. So let's go over to the bottom of page 33, and let's go ahead and draw this here. We have VTR and U and S here. We've got 90 and 72, and 67.5 and 54. Now, again, you might look at this and say, well, all the numbers are there. What are they asking us to solve for? And the answer is nothing. What they want us to do is prove that TU and RS are parallel. TU is here, RS is here. We want to prove them parallel. And so how do we do that? Well, if these lengths are proportional, then these two lengths would have to be parallel, or two sides would have to be parallel. So let's go ahead and set that up. 67.5 over 54, and then 90 over 72. You say, well, again, what are we doing with that? There's no x here. Well, all we're going to do is simply cross multiply. And the way we know that this is a true statement, we'll put a question mark here because we haven't proven this yet, is if the cross products are equal. So 67.5 times 72 is, 67.5 times 72 is 4,860. So if we cross multiply the other way, and it's also 4,860, then we know, then we can say that TU is parallel to RS. So I feel like we should have like a drum roll here as we test these. 54 times 90, yep, that is 4,860. So the cross products are equal, which means the sides are proportional, which means that now we can mark it now because we've proven it. TU is parallel to RS. And your proof would be your work, and your reasoning is that when we cross multiplied, the cross products are equal. So since the side lengths, or segment lengths are proportional, TU is parallel to RS, and that's the reasoning or explanation that you would put. Again, the cross products were equal, which means the segment lengths are proportional, and that means TU is parallel to RS. And that's it. And that, believe it or not, is it for this video. So that was nice and quick. Your homework and lesson checkpoint is on pages 34 and 35. So pages 34 and 35. So as always, review, rewind, request help, ask questions, and you're going to do great with this. So that is it for 12.1. We will see you in the next video, which is actually 12.3, which is using proportional relationships. So good luck with the work, and we will see you in the next video.